two take-home messages from that one. Firstly, we unfortunately can't blame jet skis for the loss of our oyster reefs or our fish stocks as much as we'd like. But secondly, have a look at what happened with that restoration. Its habitat is driving those fish numbers. It's a heavily fished area, that restoration site. But what we did is we added a large amount of surface area to that area as part of that restoration process. And that surface area is given a whole range of surfaces for invertebrates, which is what this talks about, invertebrates to attach to those oysters, those oyster shells we put in there and the other substrates. And it's this loss of surface area, I think, that's been one of the main driving factors that's been sort of reducing the productivity of our estuaries for various reasons. But this talks about the monitoring the natural shellfish recruitment in that oyster reef trial. So there's two components. The fish are at that site, and Ben showed there's quite a lot of fish. It shows us how much has been lost when you consider that we've actually only, I mean, this is a trial project it's a postage stamp size part of the passage, yet we get 10 times more fish from that area. So just imagine when you think we didn't know much about quantitatively about fish stocks in Pumicestone Passage until 2010. We lost most of these subtidal reefs by the early 20th century. So what the baseline for fish stocks is in Pumicestone is probably quite mind-boggling. The other thing we know we've lost is these oysters, and it's the Sydney rock oyster, Cercospora glomerata, which is the main reef-forming animal that we're interested in. And obviously part of a shellfish reef restoration process is not only will we get fish when we restore the reef, can we get the reef to a stage where it can look after itself? Can we get natural recruitment from wild oysters that remain in the system? Can we get them to be attracted to the reef, bind the reef together and form a self-sustaining system? So that was sort of what we were looking for here. And Susie covered sort of generally we tried to go about it several ways because, to be honest, we don't know how to restore a Cercospora glomerata reef. The Americans have been doing this for 20 or 30 years, been getting very similar results on fisheries productivity and other things for the eastern oyster, the Crassostrea virginica. But no one's done this for our local oysters. So we tried a few different things. We tried oyster shells, recycled oyster shells in cages. We tried initially in the first year little patch reefs of piles of oyster shells 2 metres in diameter, surrounded by loose Besser bricks. And then we tried the BESE biodegradable reefs, and they were deployed in 3 to 5 metres of water. And this whole area is 1 hectare, but there's no way in the world we were working at a hectare scale initially. We were working in little 2 metre patches. And so 9 months later, when we looked at the 2 metre diameter patch reefs, amazing large amount of this invertebrate recruitment. And so, I mean, in the end, I'm just presenting data on the Sydney rock oysters because that's the main thing we're interested in. Sydney rock oysters and other bivalves that we're recruiting. But I provided some photographs to the museum, Queensland Museum, and said, there's a whole heap of other invertebrates in here. I've got no idea what they are. Could you help me sort of key them out? And they said, yes, it'd cost you about $40,000 and X number of months, and there's probably a whole range of stuff in there. So we really don't know exactly the biodiversity increases on the invertebrate side. The fish side was 380%. Invertebrate side, I mean, we're starting with what was essentially a mud bank or a degraded historic oyster reef. So obviously huge biodiversity increases, but we can't tell you how much that increase was. When you go over it, there may be some fishermen or fishing people in this room. When you looked at the down the depth sounder, you can see our pile of oyster shells here. These are all fish. And where are they? They are right on top of the oyster reef. And why is that? It's because they're feeding on invertebrates in there and probably also doing a bit of sheltering from the current. When we had a close look at some of these shells, these were bare shells when we put them down. Remember, they were out in the sunlight for 4 to 6 months before you put them in to make sure they were sterile. Whole range of different invertebrates on them. And that's only 9 months afterwards. So when you had a close look, there's things like oyster spat, encrusting algae, barnacles, horrible things, barnacles, macroalgae, tunicates, that's all good fish food, and these colonial tunicates, botuloides, which are beautiful looking animals. That's just on one oyster shell, so it's a mini reef, just in itself. So we really wanted to get a handle on what was happening from the point of view of the oyster spat settlement. So this is, you've seen this slide already, Robbie Porter from Ozfish Central, he's a diver. And what we did was we got him to go down and grab samples of 100 shells from a couple of areas from each of those reefs that were put down in 2018. And I just counted the amount of oyster spat that I could find. We did that for every 3 months. And again, we did that, that was a 2018 deployment. We've been putting reef modules in, trying different things for a number of years. So after a while, we could compare the results from, say, the 2018 deployment to the original deployment in 2017 to get an idea of whether these reefs are accumulating oyster spat over numerous years. The one thing probably worth mentioning is that oysters in Pumicestone Passage, they only spawn naturally, usually in water temperatures over 24 Celsius. So December to March is the area when you actually get the wild spat settlements when they're spawning. So that's why we would deploy the oyster reefs basically in December, so that the oyster shells are nice and clean and ready and not getting fouled by mud and algae and other things. So you get a good window of opportunity for those spat to settle on them. And obviously we were trying to quantitate that recruitment. And the other objective for us was to get some underwater video so we could see what was happening and also get some on our community website, Restore Pumicestone, just to show the local community who were obviously very keen to see what was happening. And what we actually found, this is a summary of basically all of the data. And now the red ones, well, the first reefs we put in were the 2017 reefs, and the ones that performed the best were the oyster shells. But the BESE reefs, they're very good from the point of view, they've got a large amount of surface area, and you can see that when you put them out. It was very hard to tell what was going on with the invertebrates because you've actually got to get down there and pull them apart to see what's settled inside. So we haven't got any data on the BESE reefs, unfortunately. But anything that had oysters in it, we could go down and grab some oysters and go and count what was on there. And the cage, the oyster shells in the cages were actually the green one here. We're continuing to recruit spat quite well and were the best overall over a period of 24 months. So not only in the first year, but the second year they continued to attract spat. And we think part of that is because within the cage, you're protecting them from fish. Some of the larger fish actually can't get at the oyster shell. And the cage also keeps them up off the silt a little, keeps them cleaner, and that seemed to be very good for recruitment of oysters. So you're sort of foiling the fish feeding part of the process and learning something at the same time. So, and the other thing we noted when we went in 2018, we did some patch reefs that were larger. Every time we went to a larger scale, so in 2018 we went to a 7-metre patch reef instead of 2, those ones worked better. So the higher we went, anything that was above half a metre high, it accumulated more spat than stuff that was lower. The other thing is, do not cover your oyster reef. So the state government, in their wisdom, said in the 2018, you should put a cover on the reef to stop the oyster shell from moving around, which is silly because the oyster shells all interlock in a pile anyway. You can walk up on them when you're at the recycling centre, and they all interlock and form a sort of a nice reef straight off the bat anyway. But anyway, we indulged the government advice and put the cover over one of the reefs, and it just promptly silted up completely and became non-functional. Fortunately, there was a bit of issue with the current, ripped a bit of it off. So, the main thing is just leave the reefs to look after themselves. That was another learning thing. So we're learning as we're going along, but definitely the 7-metre diameter patch reefs outperform the smaller ones. And we're getting multi-year recruitment in the cage reefs. And some of the recruitment's quite amazing. Like overall, a good result was 1.5 oyster spat per shell. Each shell we put down, we'd get 1.5 back. That was in the cage reef. But some of these shells, you'd put one shell down and get 10 live oysters back. We'd read about it in books, but it was something to see it actually happening in Pumicestone Passage. And again, as I said before, that particular one, that was in a cage. So it could be that we're just protecting them from fish eating them. That's probably the main summary of the invertebrate component of that study. One thing we did learn, I think I mentioned it earlier, is there is actually a lot of anchor damage. So in the second year and for the larger reefs, we had the Ozfish volunteers. They made these Besser brick fences that we ran a chain around them and formed basically a fence around the reef, patch reefs in which we'd pile the oyster shell. And they seem to work really well, and they're also quite good habitat themselves with the overhang, so fish can, and we've got video of the fish actually hiding inside those little holes, hidey holes there. So overall, we have learnt certainly what not to do with trying to get these reefs restored. Certainly learnt a lot about what works and what doesn't. Vertical relief seems to be very important. Need to keep the reef pile up fairly high. Ideally, you would have the area well marked with buoys on the edges, and with advice to fish to boaties not to anchor in that area. Obviously, still allow them to fish if you're in a fishing zone, because a lot of, say for example, Ozfish volunteers, there is a little bit of self-interest. They would like to be able to fish the areas they're restoring. But there's also nothing wrong with the concept of doing this in green zones as well, if you're looking to actually overall improve that carrying capacity. Well, actually, we're not even trying to improve it. We're trying to regain something that was lost, and lost actually quite a long time. So I think I'll just leave it there, but there's more information if you need it there.
All right, thanks, Ben. We have a couple of good questions here. Was there reef expansion or other organisms expanding beyond the perimeter of the patch reefs?
We didn't look. The area outside the patch reefs, immediately outside those Besser block fences, looked like it didn't change too much. There's heavy algal turf that traps silt and sediment over the old shells. The base in this area is actually old oyster reef shell, except it stopped recruiting oyster spat decades ago because I think it gets, they're no longer getting the chemical signalling required that a clean oyster shell provides them to settle on the base, so that nothing seems to happen. It seems to become dead. But if you put the clean shell substrate in there, and it has lots of nooks and crannies, the water flows through the piles, not just over the top, but you do get a hydrodynamic cleaning effect if you do pile them up a little, because the water has to speed up when it goes over the top of the reef. And if the water speeds up, it doesn't drop the sediment out immediately. So there's a few things going on. The Americans have worked out a lot about it, but from the point of view of enhancing the areas just outside, we didn't see any of that.
Just one more quick one. How would this work in northern Pumicestone, given the shallower water up there?
Well, northern Pumicestone, again, there's a lot more sand, moving sand around. The area we are working on, as I mentioned before, was a historic oyster reef and with shell on the bottom and basically a bit of coffee rock reef just to the south. So we trying to pick areas that are still fairly hard bottom. If you could find areas of hard bottom up in the northern Pumicestone, I think around the Broadwalk is an area there that I've looked at that might be suitable. Those kind of areas, they've usually got a bit higher current flow, which is good in a way because there's a bit more scour, keeps the sediment off them, and sediment seems to be what kills that recruitment signal and things. So there are places that you can try up north there, and I think you should.
Thank you, Ben.